26 light-years from where you are sitting right now, there is a world that is currently burning. It is a place where the concept of survival seems like a cruel joke, a cosmic furnace where the temperatures hover relentlessly around 430 degrees Celsius. That is hot enough to melt lead. It is hot enough to turn the surface into a scorched wasteland of baked rock and shifting magma. This is GJ486b. It is a super-Earth, a massive terrestrial world 30% larger than our own home, locked in a suffocating embrace with its parent star. It orbits so close that a year lasts only 1.5 Earth days. 1.5 days to complete an entire circle. That proximity means it is tidally locked, staring forever into the burning red eye of its sun, one side trapped in eternal, blistering day, the other frozen in an endless, starless night. By all the laws of planetary evolution, by every model of astrophysics we have spent decades building, this planet should be a skeleton. It should be a stripped, barren rock, utterly devoid of air, floating in the silence. The violence of its host star, a volatile red dwarf, should have ripped away its atmosphere billions of years ago, scouring the surface until nothing remained but dust and silence. It should be as dead as Mercury. It should be a graveyard. But when the James Webb Space Telescope turned its golden hexagonal mirrors toward the constellation Virgo, focusing its near-infrared spectrograph on this hellscape, it saw something that made the data analysts freeze. It didn't see a vacuum. It didn't see the flat line of a dead world. Amidst the noise of the universe, hidden in the subtle flickering of light as the planet passed in front of its star, the telescope picked up a ghost. A signature. A chemical fingerprint that is undeniable and yet, in this context, entirely impossible. Water. Not liquid oceans, not flowing rivers, but water vapor. A mist. A steam. Hanging there, suspended in the inferno. The discovery sent a shockwave through the astronomical community because it defies the logic of stellar interaction. To understand why this is so terrifyingly beautiful, you have to understand the violence of the neighborhood. The star, GJ486, is not like our sun. Our sun is a yellow dwarf, relatively stable, a calm hearth for us to warm our hands by. GJ486 is a red dwarf. These are the most common stars in the galaxy, but they are temperamental beasts. In their youth, they are prone to violent outbursts, firing massive flares of X-rays and ultraviolet radiation into the cosmos. Any planet daring to orbit this close should be bombarded, day in and day out, by a wind so fierce it acts like a sandblaster on a planetary scale. This stellar wind strikes the upper atmosphere of a planet, heating the gas until it breaks loose from gravity and bleeds away into the black void. Over billions of years, a planet like GJ486b should have been peeled like an orange, layer by layer, until the core was exposed. And yet, the signal is there. Water vapor implies an atmosphere. And an atmosphere implies protection. It implies that somehow, against the overwhelming odds of high-energy physics, this planet has held onto its shield. Or, perhaps even more disturbingly, it is regenerating it. But the radiation readings were just the beginning. What the presence of water vapor suggests about the interior of this planet would defy physics entirely if we assume it is a static, dead world. The implications of this single data point are staggering. If a rocky planet, tortured by heat and radiation, can maintain an atmosphere containing water, it changes the calculus for life in the universe. We have always assumed that red dwarf systems, the most abundant real estate in the Milky Way, were hostile to life because the habitable zone is so close to the star. We thought that to be warm enough to have liquid water, you had to be close enough to get your atmosphere stripped away. It was a catch-22. A cosmic trap. If you get close enough to drink, the star kills you. If you stay far enough away to be safe, you freeze. But GJ486b is breaking that rule. It is standing in the line of fire, taking the full force of the stellar shotgun, and it is still holding onto its water. So, how did we see it? The method is an act of extreme precision. Imagine a mosquito flying in front of a searchlight 10 miles away. You want to know what the mosquito's wings are made of by analyzing the tiny fraction of light that passes through the wings as it flies by. That is transit spectroscopy. As GJ486b passes between us and its red sun, the starlight filters through the edges of the planet. If there is no air, the light is blocked cleanly by the rock. But if there is an atmosphere, the starlight passes through the gas layers. Different molecules absorb light at different wavelengths. They subtract specific colors from the spectrum. Water molecules are greedy, they absorb specific bands of infrared light. When the James Webb team looked at the spectrum of light coming from that star during the transit, they saw the missing pieces. They saw the gaps where the water had eaten the light. It was a flat line, followed by 3 distinct bumps. To the untrained eye, it looks like static. To an astronomer, it looks like a miracle. But miracles in science are usually just puzzles waiting to be solved, and this puzzle has a dark side. Because the presence of water vapor here raises a question that makes some astronomers very uncomfortable. If the stellar wind is stripping the atmosphere away constantly, millions of tons of gas per second lost to space, then the atmosphere should be gone. Unless it is being replenished. This brings us to a terrifying visualization. For this atmosphere to exist, the planet must be bleeding from the inside out. We are talking about volcanism on a scale we cannot comprehend. To keep that water vapor in the sky, the surface of JJ486b might be a landscape of thousands of erupting volcanoes, spewing steam and magma continuously, essentially creating a new atmosphere as fast as the star destroys the old one. A cycle of creation and destruction, balanced on a knife edge. The planet is literally sweating to survive. But there is a shadow hanging over this discovery. A doubt that has crept into the minds of the research team. The signal is clear. The water is there. But space is full of illusions. We are looking at a system 26 light-years away, interpreting photons that have traveled through the interstellar medium, dodging dust and interference. We are trusting the instruments to tell us the truth about a world we will never step foot on. And sometimes, the universe plays tricks on us. There is a possibility that the water isn't where we think it is. We are assuming the signal is coming from the planet's atmosphere, filtering the starlight. But what if the signal isn't coming from the planet at all? What if the call is coming from inside the house? The star itself, JJ486, is cool for a star, but it is still a raging ball of plasma. It has storms. It has spots. Dark, cool patches on its surface where magnetic fields twist and snap. These star spots are cooler than the surrounding photosphere. And in the bizarre chemistry of stars, if a spot gets cool enough, molecules can form. Even water molecules. This is the breadcrumb trail leading us into the dark. If the water signal is actually coming from the star and not the planet, then we haven't found a miracle world. We have found a phantom. We have been looking at a planet, thinking we see an ocean of steam, when in reality, we might just be staring at a cool patch on the sun behind it. The distinction matters. It matters more than anything else right now. Because if we are right about the planet, we have unlocked a new class of habitable worlds. But if we are wrong, if we have been deceived by the star, then our search for life around red dwarfs might be doomed before it even begins. The James Webb Telescope is the most advanced eye humanity has ever built, but even the sharpest eye can be fooled by a magician's sleight of hand. We are standing at a crossroads of interpretation. One path leads to a universe teeming with resilient, water-rich worlds fighting against their stars. The other path leads to a lonely, barren galaxy where red dwarfs are the executioners of planetary potential. To find out which universe we live in, we have to look closer at the star itself. We have to analyze the deception. We have to figure out if the red eye is blinking. Because the closer the scientists looked at the data, the more the perfect picture of a steam atmosphere began to blur. There was something else in the noise. A rhythm. A pattern that didn't match the planet's orbit. The signal was strong, yes. But it was arguably too strong. It was arguably too strong to be the ragged edge of a dying world, and that intensity is precisely what triggered the alarms in the data processing centers. When a signal is that distinct, that loud against the background static of the universe, skepticism becomes the most valuable tool in an astrophysicist's arsenal. The scientific team began to dismantle their own discovery, looking for the flaw, looking for the ghost in the machine that could explain away the water without invoking a planetary miracle. And the culprit they found was staring them right in the face, the star itself. We tend to think of stars as uniform light bulbs, glowing spheres of perfect, unchanging brightness. But that is a lie told by distance. Up close, a star is a chaotic, roiling ocean of plasma. It has weather. It has geography. And most importantly, it has temperature variations. The surface of GJ486 is covered in starspots, colossal magnetic storms that act like darker, cooler islands in the sea of fire. While the average surface of the star burns at over 3,000 degrees, these spots can be significantly cooler. And in the bizarre world of stellar chemistry, cooler is a relative term that opens the door to impossible chemistry. Inside these cool magnetic pockets, the temperature can drop low enough for atoms to bond, for hydrogen and oxygen to find each other in the chaos and form water molecules. This is the stellar contamination nightmare. Imagine the geometry of the situation. The James Webb telescope is staring at the star, waiting for the planet to cross in front of it. As the planet moves, it acts like a mask. If the planet happens to cross directly over one of these water-rich starspots, the telescope doesn't just see the planet's atmosphere, it sees the light from the cool spot shining through the planet. The instrument picks up the water signature, and we, the eager observers on Earth, shout Eureka, thinking we have found a wet atmosphere. In reality, we might just be looking at a damp spot on the sun. This creates a terrifying ambiguity in the data. We have two models that fit the observation perfectly. Model A, the planet has a rich, steam-filled atmosphere replenished by volcanoes. Model B, the planet is a dry, dead rock, but the star behind it has water in its storms. The graph looks identical for both. The fingerprint is the same. The difference is that one model gives us a new understanding of planetary survival, and the other tells us we have been fooled by a cosmic optical illusion. But the radiation readings were just the beginning of the puzzle. What the thermal maps of the planet's dark side would reveal next could shatter both theories simultaneously. If the starspot theory is true, it is a tragedy for our search for life. It means that the most common stars in the galaxy are actively camouflaging the truth, hiding their planets behind a veil of false signals. It means that every time we look at a red dwarf and see water, we have to ask, is it the world, or is it the star? It casts a shadow over the TRAPPIST-1 system, over Proxima Centauri, over every major candidate for extraterrestrial life we have identified in the last decade. It suggests that the universe is not just silent, it is unreliable. However, let's entertain the other possibility. Let's assume the skeptics are wrong. Let's assume the star is innocent, and the water is truly clinging to the planet. If that is the case, then GJ486b is a world that shouldn't exist, and the conditions on the surface are more horrific than anything Dante could have imagined. To maintain water vapor in an environment where the ambient temperature is 430 degrees Celsius, the planet cannot be like Earth. It cannot have liquid oceans. The physics simply won't allow it. At that temperature, water exists as a supercritical fluid or high-pressure steam. If you were to stand on the surface, assuming you weren't instantly crushed by gravity 30% stronger than Earth's, you wouldn't see a blue sky. You would be standing inside a pressure cooker. The air would be thick, heavy, and scalding. It would be a suffocating blanket of steam that never lifts, trapping the heat of the star and distributing it around the globe. This brings us to the mechanism of survival. How does a planet keep its air when a nuclear furnace next door is trying to blow it away? The answer lies in the planet's heart. For GJ486b to possess this atmosphere, it must be geologically hyperactive. We are talking about a magma world. The crust you are standing on wouldn't be solid rock, it would be a thin, shifting skin over a mantle of molten lava. The gravitational tug-of-war with the star, the tidal forces, would be kneading the planet's interior like dough, generating immense friction and heat. This friction keeps the core molten. It drives massive plumes of magma to the surface. Volcanoes would not be rare events here, they would be the dominant feature of the landscape. 1,000 Mount St. Helens erupting in unison, day and night, pumping tons of carbon dioxide and water vapor into the sky. This is the only way the math works. The star strips the top layer of the atmosphere away every hour, and the volcanoes push a new layer up from below to replace it. A planetary equilibrium born of violence. But there is a flaw in this magma world theory too. a subtle discrepancy in the energy output that suggests we are missing a variable. The existence of a steam atmosphere on a rocky world this close to a star challenges our timeline of planetary evolution. Usually, planets lose their primordial atmospheres, the hydrogen and helium they are born with, very quickly. Then, they develop a secondary atmosphere from volcanoes. But GJ486b is old. It has been orbiting that star for billions of years. To keep that volcanic engine running for that long requires a fuel source we don't fully understand. It suggests that the interior of super-Earths might function differently than our models predict. It suggests that the reservoirs of water locked inside rocky mantles are vastly larger than we thought. There is also the question of the cold trap. On Earth, water vaporizes, cools, condenses into clouds, and rains back down. It stays in the lower atmosphere. But on GJ486b, the heat is so intense that the water vapor might rise high into the upper atmosphere, right to the edge of space. There, exposed to the raw ultraviolet light of the star, the water molecules should be smashed apart. The hydrogen should be ripped from the oxygen and lost to the void. This process, called photodissociation, is the primary way planets die. It's how Mars lost its oceans. For GJ486b to still have water, it must be fighting this process with a ferocity that borders on the unnatural. So we are left with a paradox. We are looking at a signal that is technically robust but contextually absurd. We have a star that mimics life, and a planet that defies death. The scientists at the Space Telescope Science Institute are currently devising a test to break the deadlock. They need to look at the day side versus the night side. If the planet has no atmosphere, if it is a bare rock, the day side should be scorching hot, and the night side should be frozen, near absolute zero. Rock is a bad conductor of heat. But, if there is a thick steam atmosphere, the wind will carry that heat around the planet. The night side will be warm. The day-night heat transport is the smoking gun. If James Webb looks at the dark side of GJ486b and sees heat, the atmosphere is real. The water is real. And the impossible planet is alive. But as the team prepares for these follow-up observations, a new set of data has begun to emerge from a different survey, one that hints that the problem isn't with the planet or the star, but with our fundamental understanding of how gravity holds these systems together. The universe has a way of humbling us just when we think we have the answer. We are focusing so hard on the water signal, debating between spots and steam, that we might be missing the larger warning. The behavior of light in these extreme gravity wells, the way it bends and warps around red dwarfs, is subject to rules that are currently being rewritten. And what we find when we pull back the curtain might explain not just this water signal, but the strange silence of the rest of the galaxy. Because if the atmosphere is real, it means life has a shield. But if the star is tricking us, it means we are blind. And the difference between a shield and a blindfold is the difference between finding a neighbor and finding ourselves alone in the dark. Alone in the dark is a primal fear, but in astrophysics, it is a statistical probability that we are desperately trying to disprove. The uncertainty surrounding GJ486b is not just about water, it is about the validity of our entire search for life. If the star-spot deception turns out to be real, it implies that the universe is actively camouflaging its most precious assets. It means that the noise floor of the galaxy, the static generated by the stars themselves, is perfectly tuned to mimic the signal of life. It's as if the cosmos has evolved a defense mechanism to keep us from peering too closely at its children. This brings us to the ultimate test, the scientific tiebreaker that will decide the fate of this world. The James Webb Space Telescope has another instrument in its chamber, one that sees the universe in a slightly different color palette, MIRI, the mid-infrared instrument. While the initial discovery was made using near-infrared light, MIRI looks at longer wavelengths, the colors of pure heat. This is the key to unlocking the cage. You see, the temperature difference between a star spot and the rest of the star is significant, but in mid-infrared light, that contrast changes. The physics of thermal emission dictates that the water signal from a star spot will look different in the mid-infrared than the water signal from a planetary atmosphere. It is a subtle shift, a matter of analyzing the slope of the light curve, but it is enough to tell the difference between an illusion and a reality. If MIRI looks at GJ486b and sees the water signal persist with the specific brightness of a planetary cloud deck, the debate ends. The planet is wet. The planet is alive, geologically speaking. But if Mary looks and the signal fades, or shifts in a way that matches the thermal profile of a magnetic storm, then the planet dies. It goes back to being a barren rock, and the water evaporates into a stellar ghost story. We are currently waiting for that data. The telescope has been commanded to stare at the system again, to stare longer and deeper, to peel back the layers of interference. We are effectively waiting for the results of a biopsy on a solar system 26 light-years away. Consider the magnitude of what we are dealing with here. We are trying to measure the humidity of a world that is being roasted alive. If the atmosphere scenario wins, it forces us to rewrite the book on secondary atmospheres. It proves that rocky worlds are incredibly resilient. It suggests that even if a star strips a planet bare, the planet can heal itself, bleeding out enough gas to build a new sky. It means that the universe is far more forgiving than we thought, that the habitable zone is not a rigid line in the sand, but a flexible gradient where life, or at least the ingredients for it, can cling to existence in the most hostile environments imaginable. However, there is a third option that no one likes to talk about. A middle ground that is equally disturbing. What if it is both? What if the star has water spots and the planet has an atmosphere, but our instruments are currently too blunt to separate the two? This is the confusion limit. It is the wall we hit when our technology is no longer sharp enough to parse the complexity of nature. It leads to a crisis of confidence. We might be staring at an Earth-like world right now, seeing the biosignatures of a thriving ecosystem, and dismissing it as stellar noise because we are too afraid of being wrong. The caution is warranted. In science, extraordinary claims require extraordinary evidence. Claiming we found water on a magma world is extraordinary. But dismissing it might be the greater error. The history of astronomy is the history of underestimating the universe. We thought the solar system was unique, we were wrong. We thought water was rare, we were wrong. We thought rogue planets were myths, we were wrong. Now, we are standing on the precipice of thinking that red dwarf worlds are dead, simply because the data is messy. This specific case of GJ486b acts as a warning shot for the next decade of exploration. We are building massive telescopes, the extremely large telescope in Chile, the giant Magellan telescope, all designed to hunt for these faint signals. But if we cannot solve the star spot problem, if we cannot distinguish between the host and the guest, then bigger mirrors won't help us. We need better models. We need to understand the magnetic hearts of red dwarfs better than we understand our own sun. The irony is palpable. We are looking for water, the substance of life, the gentle solvent that allows biology to function. And we found it in a place of fire. It is a reminder that in the cosmos, conditions are rarely binary. Hot and cold, dead and alive, wet and dry, these are Earth-centric concepts that blur at the edges of the galaxy. GJ486b is a monster, a zombie world that refuses to be categorized. It is a testament to the chaotic beauty of planetary formation, a place where steam clouds might be rising from lava lakes, shielding the surface from the angry red glare of a temperamental father star. We often look at the stars and feel small. But discoveries like this should make us feel sharp. We are standing on a small, wet rock, using glass and gold mirrors to sniff the air of a world trillions of miles away. We are detecting the ghost of water in a furnace. Whether it is a trick of the light or a triumph of planetary survival, the signal is real. The message is there. We just have to be smart enough to read it without letting our own biases get in the way. But this struggle to interpret the data from a single star is just a microcosm of a much larger, much more terrifying problem. We are worrying about whether one star is lying to us about water, focusing on the microscopic details of spectral lines and magnetic spots. We are obsessing over the behavior of light in one tiny corner of the Milky Way. But while we have been staring at this, a much deeper crack has appeared in the foundation of our reality. The problem isn't just that stars might be tricking us. The problem is that the invisible scaffolding of the universe itself might be broken. We rely on gravity to make sense of the cosmos. We rely on it to tell us how galaxies spin and how the universe expands. But a new set of data has just come in from the Euclid telescope, a machine designed to map the geometry of the dark universe, and what it saw in the movement of 1.5 million galaxies suggests that the rules we are using to measure GJ486b, and everything else, might be fundamentally wrong. If you think a lying star is scary, wait until you see what happens when the fabric of spacetime stops making sense. Until next time, keep looking up.